Hello, good afternoon, everyone. Welcome to this session on different testing strategies implemented through OpenSearch and OpenSearch Dashboard plugins. I'm Darshit. I'm a software engineer on Amazon, with Amazon working on OpenSearch project, and I'm a maintainer of security and security dashboards plugins.
Hello, and I'm also a software engineer at OpenSearch. I'm Derek, and I'm also a maintainer of security and security dashboards plugins. Okay, so from a high level, this talk is going to go over some of the strategies in testing OpenSearch plugins and also OpenSearch Dashboards plugins. We're going to deep dive into a few topics here. The first one would be how to use Cypress to test the functionality of your dashboard plugin. And then we'll go over some backend testing strategies, including how to use remote clusters to test your APIs, and how to use the TestClusters framework that OpenSearch provides to test your plugin and also do backwards compatibility testing. And we'll also have demos for all of these topics as well. So testing is important to have right in your plugin. It allows you to have high developer confidence in any changes that are going in. That's especially important with OpenSearch, which has a weekly, or not weekly, but pretty fast release cycle of a few weeks for every minor release. This allows plugin developers not to waste valuable days in manually testing their plugin and instead rely on fully automated tests to ensure that all changes are tested. Okay, so the first topic that we're going to deep dive into today is functional testing with Cypress. So Cypress is a software that allows us to test the end-to-end user flows for dashboard plugins. So this allows us to interact with different UI elements like buttons, input forms, and actually type in them and click on buttons and see how that interacts with the APIs. So in the following demo video, we're going to go over some of the standards and conventions in order to write clean, reliable, maintainable Cypress tests. And yeah. Okay, so yeah, here we have a video. So the first step that you want to do in order to get started with Cypress is to add it as a dev dependency in your package.json, and also add some commands to allow you to run that software. So Cypress actually has two modes of running. One is the headless mode. This is mainly used in CI pipelines where you don't really need to see what Cypress is doing. You just need it to run the test. And we also have like a headed mode, which is what you use to locally debug the test and see what's going on. So the first important part of writing a Cypress test is actually the config. So this is where you'll define certain settings, such as the request timeout, response timeout for different Cypress actions. And we can also define where the tests are actually living that will be run when your Cypress test is run. Okay, and here we're going to start Cypress up in the headed mode so we can see what's going on. And here we can see the end-to-end testing that we have configured. And for this, we're going to be using Chrome. And when we open up Cypress, we can see that it has a UI showing all of the different test files that we have defined as the spec pattern for our test suite. So here we have a simple login test. Now, what a Cypress test looks like is here we have a before each block. This is meant to set up your Cypress test, download any sample data that you need, do any test setup that you want to do. Then we have the test case itself. There's two main components. The first component is doing the action that you want to do. In this case, it's simply typing in the username and password and clicking submit. And then we have the verify block, which is basically what you actually want to happen when the user does that specific action. And finally, we have after each, which is where you would tear down the test and do any cleanup that you want to do. So here we can see when we click on the Cypress test, it automatically runs the test that we have defined. So the first thing it does is run the before block. That was a little bit fast. We'll step through each action here. So before the test starts, we visit the page as defined in the before block. and then the test starts running. So here we can see, okay, so each single block actually has a corresponding component that if you hover over it, it will show you the before and after of the UI when that test was run. So in this case, we type in admin, and we type in admin, and then we click on the login button. Okay. Cool. So just to give a brief overview of some do's and don'ts when writing your Cypress test, a few of these we've already seen in that demo video. But the first thing that we want to use is data test subject. So this is how you uniquely identify your components. So instead of having Cypress look for some text on the screen, such as submit, we will tag the component that we want Cypress to click on with a data test subject. So this allows us, for example, if we want to change the text of the submit button, we don't need to change the Cypress test. We can still rely on it to click on the correct ID. Next, we ideally want to have before and after blocks, which allow us to do test cleanup and setup. This allows each test to be very concise on what it's doing, and for each test to be run in a reliable environment where all the dependencies are already set up. And finally, one don't is to try to avoid using sci.wait with an arbitrary timeout. So like, for example, 5 seconds. Instead, we want to use built-in Cypress functionality, like passing in a timeout to the Cypress request. So that will allow us to avoid unnecessary waiting around for Cypress to do its thing. Finally, so ideally, you'll have Cypress tests for each PR that goes into the repo. But for OpenSearch project, we also have this convention of using this standardized repo called the functional test repository. So this repository houses Cypress tests from each plugin and also OpenSearch Dashboards core. And the build team uses this repo in order to run all tests for all plugins and generate a report when it's release time.
Okay, so we learned about the testing strategies for front-end. Now let's take a deeper look at the back-end testing strategies. At the very core, there are 4 tests that are implemented: unit, integration, backwards compatibility, and remote cluster tests. OpenSearch excels at backwards compatibility and remote cluster tests, which I'll be showing a brief demo over and after a few slides. Unit tests, as we all know, it's isolating and verifying individual units. Integration tests check the cohesiveness of these units end to end. Backwards compatibility here is very important. As we publish multiple versions, we want to ensure that they are stable. The features are stable across these versions. That's where backwards compatibility tests shine. Remote cluster tests are usually used for validating API correctness across different versions. They run tests against a cluster that is spun up outside the JVM. We'll talk about that in a little bit as well. Unit tests, best practices are you should isolate the functionality, utilize mocks to avoid external dependencies, and the test itself should be clear and concise. We should also implement code coverage monitoring to show that there is thorough testing that has already been implemented. This is one of the practice that is followed within OpenSearch as well, if you look at the CI workflows of different plugins. For integration testing, it's an extension of unit tests where it checks the validity of the features end to end. However, these integration tests do not account for the unknowns that were introduced over time. That's where backwards compatibility tests chime in. BWC tests or backwards compatibility tests catch any subtle changes that that may have gone unnoticed during those upgrades. It's very important to analyze those breaking changes to catch them early, because these issues can lead to degraded performance or even a broken cluster down the line for next major release. For remote cluster, it's similar to backwards compatibility testing. It utilizes similar framework. However, these tests are run mainly for validating API correctness or validating the functionality. So you have a cluster running, say, any part of the world. These tests utilize command line arguments for, say, URL to that cluster. And in case where it's secure cluster, it asks for a user and password to access that OpenSearch cluster. Best practices include like verifying authentication flows, ensuring that data is consistent, and different API versions are compatible. Common pitfalls are generally overlooked edge cases, timeouts, or network duress, or missed backwards compatibility in certain APIs. The idea here is to anticipate these risks early and design targeted tests so that we can catch them before they hit or before they are shipped with the distribution. So we know like different testing strategies so far, but how are they actually used in OpenSearch? OpenSearch defines a very versatile framework called TestClusters. This is lesser known part, but a lot of plugins have used it over time. It's a wrapper around the Lucene test case. If you go and browse the OpenSearch code base, you'll see OpenSearch test case file, which is an extension of Lucene test case. And OpenSearch test case itself defines the intact test case, that runs the cluster within the same JVM as tests are run. Another extension is OpenSearch RestTest case, which is what we were just talking about a while ago, which allows you to build clients to test against remote cluster. And then you have single node test case, which is used to check or used to check dependency injections for unit test case in case you don't need to mock or you have the necessity to utilize them instead of mocking them. For the very first demo is about backwards compatibility tests. So here you can see I'm going to highlight a few important blocks. So first one is RestTest plugin application. The other one would be the TestClusters framework itself. And the third important part would be the test framework dependency to be added to the Gradle file. For this particular demo, I'm using a concept of previous and next version. This is derived. This demo is actually live in security, so if anyone wants to play around with it, just go to security plugin and check it out. And here, TestClusters use this methods or tasks supplied by the TestClusters framework, where it asks you what plugins you would like to install. In our case, since it's security, we do provide some extra configuration listed as such. There are plugin files that it takes. I'll show you briefly how like those are structured after we go through this demo. So we start with a 3-node cluster. In our case, we are testing against 2.19.2, and the next version would be 3.0.0 at the time of demo. So we start with 3-node cluster for 2.19.2, then we upgrade one of the nodes, and then we upgrade another node. So we have 2 new nodes and 1 with old, and finally we update the last node. This concept or this process is called rolling upgrade. It's very widely used across OpenSearch, where we update node by like each node instead of just killing the whole cluster and then rebooting it. Another important method that is supplied that I'm going to be highlighting here soon is the upgrade all nodes and plugins to next version. This is something that is supplied by the TestClusters framework. It's very powerful. So if you're trying to look into, say, this particular method, go to the OpenSearch code base and you will see like how it actually ends up updating the plugin and the node itself to the next version. Okay. At the very end, I have defined a BWC test suite task, which basically runs all of these tasks in a flow. I have added all of the test files that were declared within the sub-project. So I'll just walk through what the tests itself are doing. Excuse me. And then we'll run the tests itself after I show you the structure or like where the zips sit for this demo. So if you look at the left side, I'll open the resources folder, and you'll see like 2 folders, the 2.19.0, 2.19.2, and 3.0.0 beta 1. So these are the 2 versions we'll be testing against. We'll start with 2.19.2, and then we will be upgrading each node one by one to 3.0.0. In our case, since it's security plugin, we supply the static certificate files to ensure like smoother testing experience. In your case, you could supply on-demand certificates as well. As you can see in the test file, I'm using ingestion and search functionalities and testing those against different scenarios. I have some switch case or if-else blocks that test against the older version, the mixed version, and the completely upgraded version. And I have defined, like, in those are defined in an enum. Okay, I'm gonna run these tests, but for the sake of this demo, to speed it up, I'm just gonna skip to the end of the result, and we'll see that these tests are indeed successful. So let me run that. And yeah, so these tests were successful in about 2 minutes and 41 seconds. It took a little bit longer because it's ingestion and search, but you could write a simple sanity test to verify like certain APIs as well. Our next demo is taking a step deeper into what these remote cluster tests are. So I don't know if you caught the part where the backwards compatibility test extended the REST test case. We'll dive deeper into what that actually is. So in this particular scenario, I'm using a sanity test using the REST test case. This sanity test does nothing but verifies whether the security plugin is installed correctly, and also checks whether you can log into the said cluster. So in this demo, we are going to cover 2 parts. One is what happens when I turn off the cluster versus what happens when the cluster is actually running. For the sake of this demo, I'm using the cluster locally on my machine. I will walk you through the demo, the integ test remote class or remote test task, which is what is used to accept the URL parameter for the remote cluster running. And in our case, since it's security enabled, we'll pass in few more arguments. Fun fact, this is actually used in today's release cadence for OpenSearch, where it runs these tests against a simple sanity check for security plugin. As you can see, I'm passing in few arguments for the security, saying that the cluster is security enabled. I'm passing the user and the password itself. For simplicity's sake, I'm just using IntelliJ's command, and we'll see that in a few seconds that these tests will actually pass. Once that is done, we will go and actually turn off the cluster and see what happens. Awesome, so the tests have passed. I'm gonna go to the cluster and I'm gonna turn it off, and I'm gonna try to run the cluster again. I'm gonna try to run the tests again, excuse me. Okay. So I've run the tests again. The expected output is that the test should not run because the cluster itself was closed, so there is nothing to test against. So this is an effective way to understand whether the testing cluster is up and running, and whether your tests are wired correctly. This is a simple demo. Like, there are different implementations across different plugins already available. So if you're curious, just take a look. It's easy for any plugin developers, especially with custom plugins. This might serve as a good starter point for those people, like looking to contribute and test against remote clusters. Another flavor of the integration test is testing within the same JVM cluster. So let me walk you through a quick demo for that one as well. For this use case, I'm using anomaly detection plugin. And as you can see, I'm using OpenSearch integrtest test class. And within the Java doc, you'll see that this is used to spin up the JVM, or spin up the cluster within the same JVM. This just tells that every time the test is run, a cluster is spun up, and when the tests are done with, the cluster is brought down. For this particular test, I'm using one of the batch tests, and as you can see with the annotations, that I'm using 2 data node cluster, and it's within the test scope, so it will run, but only for this particular test. Again, for this demo, I've just passed, like I've just used already existing run. And as you can see, like all of the tests were successful relatively quickly. This structure is also very widely used across different plugins. You'll see different flavors of it, like security plugin defines its own local cluster. Like anomaly detection has this, KNN also has a variant of this where they install security plugin to test against a secure cluster, and another variant where they do it without a secure cluster. Okay, so now we have looked at different testing strategies. How do we actually utilize it in OpenSearch? OpenSearch, we set up automated CI pipelines, so almost all of the plugins that you look at has some flavor of CI control that has implemented and requires these CI checks to be successful. In addition to that, we have enforced minimum threshold test coverage that we need, so if the changes are not tested thoroughly, we as maintainers do not generally accept it without the test coverage being met. Another thing we use CI for is as a quality gate for changes. A successful CI run basically allows us to give, allows us some confidence that the changes coming in, especially the changes that are brand new for new features, are well tested and how do I say, like well tested, while the failures in those test cases highlight the issues early on, so that if we try to ship it to production, we know that these tests or these edge cases have been covered. In addition to this, I'm not going to dive deeper into this portion yet, but we run integration and smoke tests during our release pipelines. These are very crucial. This is like last check before we actually publish release artifacts. In addition, we also run benchmark tests to catch regressions in latency, throughput, and resource usage early to track performance of different versions over time. By automating these checks, we make our release cycles faster, safer, and more reliable without depending on manual validation, as Derek mentioned earlier.
Okay, just to summarize our talk today, it's really crucial to keep tests maintainable and readable. So this is, for example, if you want some functionality to change, you want to be very clear on why a test is failing and whether that failing is intentional or not. And that really helps with also if you're modifying that test, you know like what to change about that specific test. Next, we should always try to implement backwards compatibility tests, especially when developing new backend plugins and new APIs, to make sure that we have backwards compatibility and we will not introduce breaking changes into minor versions. Finally, we should try to automate as many tests as possible, ideally all of them, into our CI/CD pipeline, so we're always running them on every new change and we know the quality bar is there. Finally, we should always try to learn and adapt to the changing situation. For example, for a security plugin, we've parallelized the unit tests and integration tests so they're running faster. We can get changes in faster and have more confidence there. And finally, like some good resources to use for Cypress, the public documentation is really good in knowing what a command is supposed to do and when to use it. And you can also reach out to us on the community forums and GitHub if you have any questions.
Yep, that's all from our side. Any questions?
Questions?
So for the security plugin that you are responsible for, how much percentage do you cover with your tests of all your functionalities?
At present, it's closing in on 72. We are trying to push it up. We were about at 50 when I joined, and now it's at 72. So
okay.
I think I can safely say that security plugin has the best CI run across all plugins in OpenSearch.
And are you working with the rest of the plugins to bring them up to speed, or?
Yes and no. Yes, they do take inspiration from us, but we recently implemented changes around CI where we parallelized a lot of tests. So what used to happen earlier was that it would take like 1 hour for a simple CI to be run, and if one test fails, the whole CI fails, which becomes very hard to debug. So our community partner Eliatra is here. They implemented a change where they parallelized and divided into different components. So now if you look at the CI, there's DLSFLS, there's certificate tests, there's SSL tests. So this allows us to take or use the CI power of GitHub efficiently, as well as separate concerns, so we can focus on what tests are failing. It also allows us to track like breaking changes for that particular plugin. Yeah. It makes it easier. Yeah. I don't know if any other plugin has implemented that strategy yet, but I would love to see that.
Thanks.
Yeah, just to add on to that, like the software that we use, which is CodeCov, there's a specific feature that you can do, which is like have a check that the patch or like whatever the PR is introducing is at least of the same percentage of the general repo. So you can ensure that the percentage is not going to decrease with any change.
Yeah.
Any other questions? Thank you both.
Oh, I think we have one more question.
Go.
Hey, so my question is about tool selection. Why did you decide to go for Cypress instead of something more mature like Selenium for the front-end tests?
I was not there when that was decided, but I think that's just the general standard that OpenSearch project has gone with.
Oh, got it.
We used Jest for a while, but then we moved to Cypress. And I was also not like very aware of why that decision was made, but Cypress does make a lot of testing easier, and it's been used across all of the components. So we have functional test repo that Derek was mentioning, which combines all of the plugins and runs tests cohesively during release pipeline. So that's something that helps with Cypress.
So since Cypress is JS-based, does it also have support for headless browsing?
Yes.
Oh, cool.
Yeah.
Thanks.
Yeah. Well, all of our CIs run in headless mode. For this demo, we just ran into headed mode, but it does consume CPU like quite a lot if you run in headed mode. So, and especially if you run in Chrome.
Got it. Thanks.
Yeah.
Thanks, Wes.
Last chance. Thank you both.
Thank you, guys.